This is a wet pipe sprinkler system, which is a water-filled piping network supplying sprinkler heads. The riser that we have here is a wet riser with an alarm check valve. The alarm check valve provides two things. It checks water flow into the system, meaning the water pressure will be higher on the system side in general than it will be on the supply side. The alarm check valve allows for one other function, and that's to create a mechanical alarm through water flow. It does that once water flow is established through the riser. The alarm valve clapper opens up. There's ports in the seat which are open. The ports are filled with water, and through a channel in the valve, exit the valve through trim piping. Trim piping is half-inch piping connected to the valve in general to either create an alarm or to drain the system. When the clapper lifts, water will exit the valve, rise through the trim pipe into this empty chamber, which is called a retard chamber. And a retard chamber is a mechanical delay prior to an alarm. Water will fill the retard chamber and activate a water pressure switch or a water motor alarm. Once the retard chamber is filled and pressurized, the switch will be activated and an alarm will either be caused locally or at a central station. When a water flow is established through the valve, the way to stop the water flow is to close the control valve. On our riser, we can simulate a water flow through a valve in the back. This would either be an open sprinkler head or it could be piping that would be broke on a system where the water flow is established. At this point, we'll open the valve, establish our water flow. Water is flowing through the riser, lifting the alarm check clapper, and water is exiting the trim, filling the retard chamber, and pressurizing the switch. As you can see from our lights, we now have a water flow. The way to stop the water flow through the riser is to close the control valve. Once we close the control valve, we have a condition where we have a supervisory alarm through an electronic supervision on the valve. Once the water flow is ceased, we need to drain down the riser. The riser is drained through a valve called the main drain. The main drain valve is connected to the valve trim. We simply open the valve to drain down the riser. Once the riser is drained, we're going to correct our problem in the field, which may be replacing a sprinkler head or fixing piping that could have been broke. In this case, this is the way we would correct our condition. When we refill the system with water, we need to open our inspector's test valve, which is generally located remote of the riser. It could be your farthest point from the sprinkler riser. So we would open a 1-inch valve. The reason we're doing that is to purge air through the system when we're filling it. So at this point, we're going to establish a water flow through the riser, which is in general a 2-inch water flow through our main drain. Once we've established a good water flow, we're able to close our main drain valve and allow the system to fill. Once we've purged all the air from the system, we're able to close our inspector's test valve and establish our water pressure in the system. Once water flow is ceased, we're able to open the control valve entirely and clear our supervisory alarm. Once the system is back in service, your supervision or your supervisory station, central station, or local alarm monitoring station should be called and notified that the system is back in service.